Hi guys, good afternoon. So last week we did the first 7 questions on this sheet. Could you do the remaining ones, starting with question 8 today? So maybe, I guess some of you already done, but if you haven't done it, especially those guys on the Zoom, can you please do question number 8? I'll give you a few minutes now. Okay. I'll give you a few minutes to do question 8, then I will show you how to do it. I hope you can see this clearly. Is it the first one or is it the second one? So how was the first one?
No, I don't know. It was good. This one.
All right, guys. So this is question 8. To show you how to do it. So this is the CDF given to you, right? So in order to find the var, you set this equal to p, which implies that Alright, so this is the formula for var is sigma times minus log of p power minus 1 divided by alpha. Okay, is that okay with you guys? Any questions on this? I'm sure all of you got this right, yeah? Yeah, okay. Okay, the next thing you need to do is to find the expected shortfall. So use the formula for it. Alright, now to do this integration you need some kind of substitution, right? I mean, obviously there are different substitutions you can try. The one I would, well, I mean, there's no rule like which substitution will work and which will not work. So it's something that you learn by experience. So in this case I would try the following. Yeah. So under this when t is equal to 0, log of 0 is minus infinity, so this will be plus infinity, and you have minus log of p. Alright, so this will become x. Okay, now this minus sign here, I'm going to use this minus sign to switch the limits. So this, you have the minus sign here. Okay. Now this is where you need to use like a special function, a non-standard function. I think I mentioned this last time. This is you need to use. There's something called the incomplete gamma function, which is defined as follows. Right, and this is the and some people, I mean, there are different names for this function. There are different names for this function, and some people call it complementary. I mean, it doesn't matter what they are called. The fact is, you should be able to use them. That's what matters. Some people call it the complementary incomplete gamma function, and some people call it the lower incomplete gamma function. Some people call it the upper. So it really doesn't matter the name. I mean, the name doesn't matter. What matters is being able to use the definition that I gave you. All right, that okay. So I mean, what the name of the function really doesn't matter, right? So using this definition, this function here, you can write the above as this, right? Okay, so sorry, I have to erase this. So that's the final answer to question number 8. All right, so that completes question 8. Are you guys okay with this? Any questions on the Zoom, guys? Are you okay with question 8? All right, you sure not? You sure? Okay, then can you go to the next question, please, which is question number 9. We're done with question 8. All right, guys, can you start working on question 9, please? All right, guys, let me show you. I'm sure most of you have done it, but if you haven't done it, let me show you how to do it. Right? So this is Q9. So your CDF is is the Weibull CDF, which is given by this. So in order to find the var, you set this to p and solve for x. All right, so this is the solution that you get for x. So hence the formula for var is this. Yeah. Okay, guys. Yeah. Now, in order to find the expected shortfall, all right, use this formula. Now, once again, you need a substitution. The obvious substitution to make in this case is minus log of 1 minus t, right? X equal to minus log of 1 minus t. So your t will be 1 minus this. Yeah. So your dt by dx will be this. Okay, guys? Are you guys okay so far? Right, so let's put this in a box. Yeah, so you should substitute this into the integrand. You get sigma by p. The limits of integration, 0 will go to 0 and p will go to minus log of 1 minus p. Right? So you get this. Okay, now this integral is also non-standard function and is known as sorry, this is t, so excuse me, it's t, not x. All right, it's known as the incomplete gamma function. I mean, the one we used in the previous question is known as a complementary incomplete gamma function, whereas this one is simply known as the incomplete gamma function, right? And some people also call it the lower or the upper incomplete gamma function. But once again, it doesn't matter what name. The name doesn't matter. The only thing it matters is be able to use the definition, right? Definition of the function. Okay. So let me put this in a box. Right. So this guy here becomes so that's the answer to question number 9. Okay, so that's the expression for the expected shortfall of question 9. All right, guys, any questions on this? Any questions? What? Guys, can you hear me on the Zoom? Hello? Okay. Can you guys do the next question, please, which is question number 10? I think question 10 is similar to some of the questions we did earlier last week. So, all right, so this is the formula for value at risk. Correct me if I'm wrong. Hope it is correct. Okay, now to find the expected shortfall. Now, in this case, C is a positive number, so, well, it can be negative, but it can be negative, but then you will need to consider the case where C is -1, because so we're gonna here we need to assume that C is not equal to -1. Right? Otherwise, this is not valid. You know what I'm saying? If C is equal to -1, then you need to use the log, right? So we need to assume that C is not equal to -1, right? So in this case, the result, the expression for ES will be this, right? So this is the expression if C is not equal to -1. Okay. Now, if C is equal to -1, then the answer will be different, right? Because let me show you, right? So in the case if Right, so that's, if c is equal to minus 1, this is the integral that you need to work out. Right, so this will be t, and here minus minus gives you log yeah, and that's it. So this is the answer, because the limit at 0 is 0. So this is if c is equal to minus 1. Alright, so in summary, you have two different answers, depending on you have alright guys, so that's the answer for question number 10, unless I made some stupid errors. Okay, is that okay guys? All right, can you do question 11 please now? Question 11. So this is question 11. Question 11 is, you are given the quantile function, which means, remember the quantile function is basically the inverse function of the CDF. So you are given f inverse of p as this, yeah. So basically, what you're told is you're already given the var. So basically, this is your var. Remember, the quantile function is equal to the var, or the var is equal to the quantile function, right? If x is a continuous variable, right? So all you need to find is the expected shortfall. Just for easiness, let's assume lambda is not equal to -1, otherwise it will get into problems, all right? Otherwise you'll have to do it separately, which I don't have the time to do it now. So let's assume that lambda is not equal to minus 1. So the integral of this is t plus so this should be t, not p. All right. So you get 1 over p lambda if you put t equal to 0, this is 0 and this is 1. Alright, so this is what you get. Alright guys, so yes, I have assumed that lambda is not equal to minus 1. But if lambda is equal to minus 1, then you know what to do, right? You have to do it using the log thing, right? You have to do it differently using the log thing. And I really don't have the time for that now. So that's question 11. And question 12, question 12 is you're told that f inverse is equal to p to the power beta minus 1 minus p to the power gamma divided by delta. So again, let's assume that beta and for easiness, just for being lazy, let's assume that these are not equal to minus 1, right? So the expected shortfall is gonna be this, yeah? Now if you do the integration, you get this, and if you take the limits, you get this minus 1 divided by gamma plus 1. Right, so that's question number 12. And finally, I don't know if I have the time, finally question number 13, which is the last question. I'll just do it quickly. This is question 13. You're told that the inverse function of f is c times p to the power alpha 1 minus p to the power beta. So this is the same as what? Yeah. So you just have to find the expected shortfall, which is c divided by p integral from 0 to p t alpha 1 minus t beta dt. Now you may remember something known as the incomplete beta function, which I introduced a couple of weeks ago. So using that, you can see what you have here is the incomplete beta function with your alpha, with your a equal to alpha plus 1 and your b equal to 1 minus beta. Do you guys remember this? Yeah, this is the incomplete beta function. If you don't remember, I will write it down one more time. This is known as the incomplete beta function at a and b. incomplete, better, function. All right, guys, so this completes question number 13 and also completes the tutorial sheet. All right, guys, so have a good weekend, and any questions you guys have, please feel free to contact me by any means, right? All right. Take care, guys. Sorry, somebody waiting for us, I think. We need to... Yeah, that's... I don't know. Not sure why. Are you guys okay with this? So if you have questions, please let me know. Not difficult.
No, I really know you are.
Okay.
I don't remember this.
Right, guys. Have a good weekend.
Thank you.
See you.
My eyes hurt so much that it wouldn't like behind the computer every day for like 12 hours minimum.
Well,
That's hard. Yeah, because it hurt. That's why.